Hi there, here is Ali, and I'm here to represent the BID system for a mass spring damper system. So first of all, I'm going to do it step by step as it is needed. So we'll open MATLAB at first, then we will write Simulink. So we need to represent this equation in the Simulink for MATLAB. So which is acceleration equal to 1 over m times force minus d over m times velocity minus k over m times distance. So I will start with my BID controller. Yep. Then with the add gate, it would be plus minus minus, and this is because the signs here for f is plus and for the velocity is minus and minus for the distance. So going back, so the first wire is for f. So we will need an integrator to get the velocity, then another one to get the distance, and our output will be connected by a scoop. Yeah. So from the equation here, we know that the velocity is multiplied by constant d, and the distance is multiplied by a constant k. So going back, we'll start with the velocity. We'll write again gate multiplied by constant d. Then the distance, which will be multiplied by constant k. And bear in mind here that the distance and the velocity and the force are divided by m. So here we will divide by m by multiplying by 1 over m. So as we are asked to represent it for a sine wave, so we will write here a sine wave. And as it is a BID controller, we will need the error. So we will need a feedback from the result. So here, and we will get the feedback from there, and we will connect it to our PID controller. So we will set our values for our M, D, and K. Let be anything. So for K, 5 or 4, it doesn't matter. And for D, let it be, wait, let it be 3. For M, let it be 2. We will run it. It will take a while. Yep, and let our period will be 330. So we'll see our result here. Yeah, it will take a while. So it seems to be a sine wave, but not that good. So we'll try to increase the period, the integration, the integral, and the derivative. So let it be, for example, 10, 10, and 10. And let's see the result here again. So it seems to be better, but you'll see that here it's below the 1, which is our range here, 1 and -1. So let's use the automatic tool. It will take a while again. Yeah, so here was our previous one. You will see that here the period wasn't that good. So we'll try to increase it here. Mm. So it seems to be better here now. Let's try to update it. So let's see our result here in the scope now. Yep, it seems to be better now. You will see that it's from 1 to -1, but you will see here as we zoomed in, none of not none, but most of them are not that accurate. So you'll see like here an angle where it's supposed to be like a curve. So with more, as we more, uh, just let it to be like perfect, that we will get a perfect sine wave. So that was the whole process for a PID controller, and yeah, that's it all.